before the African campaign in 1942, plans were being made for the invasion of Europe and for the production of supplies which would assure victory in the battles of France and Germany. Tanks, aircraft, and vehicles of all kinds would be required in large quantities, and millions of gallons of petrol would have to be transported to the fighting fronts. For this purpose, special petrol containers of the U.S. Army design, appropriately called Americans, were to be used, and in order to save valuable shipping space, it was decided to assemble the cans in England. This lakeside site was ideal for the factory. Building was pressed forward, and roadways and drainage were completed before the machinery arrived from America. Cartons stacked to the roof contained parts made in America and sent in compact form to save shipping space. Each carton weighs 93 pounds, and a day's supply for the assembly line means moving about 30 tons. A good job of work. The pile soon diminishes, and another space is cleared to receive more en route on the high seas or being unloaded at the ports. Snipping the steel bands and opening a carton that has been packed for a 3,000-mile sea voyage is not as simple as it looks, but gravity conveyors assist. And the next operator has already acquired a knack of separating the parts and sorting them. Bottoms go one way, heads another. And if you were quick enough, you could see the other parts fall into boxes provided below. The cardboard cartons are recovered and sent to the mills for repulping. Before removing the protective oil coating, some operations are necessary. The vent hole in the head is reamed to size. You will see a tube fitted into the hole later. This tube allows air to pass into the can as the contents are poured out. Here the handle is notched to accommodate an identification tag, which is attached when the can is filled in order to indicate its contents. The tag has been designed with raised figures so that it can be read by finger touch in the dark or with the light of bursting shells. You will see that the handles are placed on tubes, and this is done to ensure that they are placed in the baskets in correct position for degreasing. Off they go to be cleaned of the protective oil coating, which has brought them across the high seas of the Atlantic in good condition. An overhead electric crane takes the baskets into and out of the solution, which removes all grease. The crane's speed is retarded to prevent raising the vapor of the solution and drawing it out of the tanks. For this reason, the baskets accommodate a large number of parts. This operation makes sure that the gasket face is flat, so there will be petrol in the can when it is wanted. Parts clean and bright are assembled. The vent tube is attached to the inside of the head by 4 spot welds. Over goes the head, and the handle is attached in the same way. 14 welds hold it firmly in place, cementing the steel together stronger than any single thickness of the metal. The operator skillfully controls the position of the welds with the help of the jig attached to the machine. 6 operators doing the same assembly on spot welders fill up the hooks on the overhead conveyor, which takes the work to another part of the factory where it is required. Without the conveyor, another 12 tons of work would have to be moved by hand daily. We leave the handles to see some of the heavier parts. Here, an overhead 5-ton traveling crane picks up 2 packets of steel sheets at a time. Each packet weighs 1 ton. They've traveled the Atlantic in a convoy protected by British and Allied sea power. Each bale has a protective wrapping, and the sheets have been oiled to protect them from rust. They've been cut to the correct size and will soon be formed into the bodies of the petrol cans. After being unpacked, a hand crane brings the sheets alongside the press, 1 ton at a time. The operator has mastered the machine and developed a rhythm in feeding the 5-pound steel sheets at a rate of 720 an hour. In they go, and the crank of the 150-ton press responds to the touch of a foot lever. On the reverse side, the guard has been removed, so that we can see the formed and embossed sheets ejected as the plain sheets are fed in the other side by the operator. Out they come from the jaws of this powerful machine, pressed into shape. Synchronized with the flow of parts, two operators work the folding press in unison. The body of the can takes shape in this folding operation. The gravity conveyor takes them away with the help of an operator. A final closing form is applied before the body of the can is passed to the welding machine along more roller conveyors. Here, the body is stitch welded to hold it together until it is permanently sealed. The operator places the folded pressing into the machine, holding the edges into guides which control the correct amount of overlap. Two spot welds are placed along the overlapping edges by the operator pressing a foot lever. This is a straight seam welding machine, and two operators attend to it in order to deal with the volume of work. The body is placed between two copper wheels which come together by air pressure and electrically heat the steel to melting point so that it unites. Water is used to cool the machine and also runs over the parts so the shape is not distorted. The weld is accomplished by applying heat and pressure with a series of spot welds. Two operators keep the machine running at full speed. A general view of the welding department is seen. Three seam welders do the straight seaming of the body, each producing 240 an hour. Two machines stand by ready to be used when any one of the operating machines is taken down. The operators soon acquire skill in guiding the parts through the machine so a steady output is maintained. The timer is the heart of the machine, and it's necessary to check to see that it's operating correctly. Here the chief engineer and electrical foreman inspect the electronic timer and appear to be satisfied with the way it is working. After being joined by welding, the body is finally shaped in a horn press so that the complementary parts may make an airtight can. The head assemblies, traveling on the overhead conveyor, now reach the stage where they're to be used, and after being removed and inspected, are placed on a gravity conveyor which delivers them to the next operator in an accessible position. The bodies take a course down the opposite side on a gravity conveyor, and the two parts are assembled in a special jig by pressing the sides of the body inwardly to allow the head to push on. This machine is operated by air pressure, and of course the operator also has to exert some force. By hand alone and without the machine, however, it just isn't possible to assemble the parts. Again, stitch welding is employed to hold the parts together until they're finally seamed. The spot welds must be placed correctly, and here much skill is employed to attain speed. The charge hand keeps a watchful eye on the quality of the work. Each part now weighs about 8 pounds, and it's a full-time job to unload the conveyor. The upper seam is now welded, and this is probably the most difficult operation in the process. Several machines designed for the purpose are employed. The operators have acquired great skill, which makes this job look easy. In starting to do this work, it's like being on ice for the first time. The metal is molten, and it's not easy to guide the can around its corners in a straight line. The flashes you see are pieces of molten metal flying through the air. After welding, the can is placed in an air-operated machine for testing underwater. When the can is submerged, air at 10 pounds pressure is applied internally. If there are any leaks, tiny bubbles rise to the surface. It's necessary to revolve the fixture so that any bubbles, however small, are clearly visible. 7 welding machines, each having its adjacent tester, are required for dealing with the flow of production. A view of this section shows the electrical, air and water services connected to the machines. A maze of pipework and cables. We are beginning to see a can take shape, but the tea bell is sounding and reminds us that tea is waiting. A well-earned tea break is always acceptable, but strangely there is no rushing. It's more like a seaside promenade. Perhaps it is the rush of cans that makes a gentle stroll to the canteen and relaxation. And coming out into the open air is always enjoyable, whether it's bright or raining. Air raid shelters are placed adjoining the dining rooms and are near the factory buildings. Just before the picture was taken, a cloudburst threatened to make outside pictures impossible, but cleared in time for tea. Everyone leaves the factory for this 15-minute period, except those who are required to adjust or repair any of the machines. When this work is finished, they follow the others. The canteen overlooks the gardens and lake, and in July, bathers stroll over the lawns during the midday break, but today it's better inside, and tea with a cigarette is enjoyable. The service is cafeteria style, and as you see, almost everyone has been served and already passed on to their tables. It's good to see little groups together. Everyone appears to be in good spirits and friendly. The canteen has a southern aspect and generally enjoys a cheery, sunny view stretching out over the water. And good health to you, sir. There are 2 tea breaks, one in the morning and one in the afternoon. It's usual to see the same faces in the same places. There's plenty of space to enable all to find a table where they can talk quietly with their friends. All the problems of the world are discussed. The topics today appear to be light-hearted and directed mainly at the cameraman. The 15-minute break comes to a close, and back we go in the same enthusiastic way as we came out. The setter is just changing the copper wheels on one of the welding machines. Due to great heat and pressure, the wheels mushroom and must be trimmed in the tool room where the other factory tools are also made and repaired. Great accuracy and plenty of patience is required. No rushing here, otherwise the entire factory might come to a standstill. Welding wheels must be changed 3 or 4 times daily. The operator appears to be taking this sealing very easily. Now and again one is rejected, and this is how it is repaired. Torch welding adds molten steel to cover the place where a leak occurs in a very small percentage of cans. The chief electrical engineer shows us the transformer house. Let's look inside at the neat arrangement of this vast power. The electric current comes into the factory at 6,600 volts and is reduced to 440 volts in passing through these transformers. High voltage is dangerous, so it's better locked up. The voltage of the welding machines is quite different, being reduced to about the same as that in a hand torch. The difference is the volume. And one machine takes about the same electrical energy as 12,000 people shining their hand torches at one time. 7 welding machines with 7 adjacent testers are needed to handle the volume of work passing through this operation. We pass from one to the other. The repair charge hand is working on this machine. Passing down the shop, we see the charge hand inspector collecting the test reports. This looks like an operation applying an artistic or camouflage coat of paint. No, it's an air blast to remove the excess water before the cans are finally cleaned. Let's follow the process and watch this stream of what resembles petrol cans, but without bottoms, and see how they are made to withstand the rough treatment they receive in use. The parts enter an automatic degreaser where they're cleaned. The chief inspector and the works manager have found a quiet place to discuss the quality of the product. It's good to see the fluorescent tube lighting and so much of the surrounding equipment painted white. Overhead, the cans emerge from the degreaser and circle to the lower level, being carried to the machines for attaching the bottoms. The bottoms are attached in a unique manner. Again, special purpose machines are used, built for mass production. It's a spinning operation to fold the bottom and lower flange of the body into a double seam so that they are locked together permanently. The conveyor brings the parts to the operator on her left and takes them away on her right side. Time and motion studies are taken of all the operations. Let's see what really happens in slow motion. The bottom is placed on the machine. The operator removes a degreased can from the conveyor, placing it over the bottom. She presses a button to force the parts together. The rolls are forced into the edges as the parts rotate, making an airtight lock. The can revolves 6 times and is finished. The setter strolls up to see why the outgoing line is not full. He finds it's only the cameraman who's removed the cans to take these pictures. As the cans may be dropped from aircraft, the bottom is reinforced by welding. This is similar to the circular welding seen previously, but it's arranged automatically as the parts have been previously double seamed and the edge forms a guide for the welding wheels. One operator tends 2 machines. The wheels rotate, causing the steel to become red hot along the line of the seam. The water is again used to cool the rest of the can and the welding wheels. The cans travel to the testing machines where the bottom seam is tested for leaks. 6 testing machines are needed to deal with the flow of work. The bottom of the can is immersed in water and air pressure is applied to the inside of the can. 10 pounds pressure registers on the gauge. The operator looks for air bubbles coming up through the water, and if there are none, the can is passed OK. Traveling on, the conveyor takes the cans past 2 inspectors, who with critical eyes see that the outside and inside surfaces are in condition for painting. A light is inserted so that the inside can be seen more clearly. Special indexing machines carry the can upside down over a spray gun for painting the interior of the can. The gun passes through the opening in the can and covers the interior with petrol-resisting paint. As the machine turns, the operator places one of the cans to be painted on the machine and removes a finished one. 2 machines take care of the output. We now see a different type of painting. It's carried out by pouring the paint over the outside. A plug is placed over the can opening and the conveyor takes the cans through a paint bath, after which the plugs are removed and sent back to the first operator to be used again. The shining steel quickly changes to brick red, forming a rust-proof undercoat. They are inspected immediately, and additional paint is applied by a spray gun around the closure which has been covered by the plug in order that no part is left uncovered. This line of cans is about to enter the oven where the paint is baked. Cans with the interior paint only applied are placed on each alternate hook and go through the oven between cans which have the outside primer coat. The oven is 92 feet long. Out of the oven, fumes are drawn out of the cans by inserting suction tubes, a process which has since been eliminated by introducing a system of fans. Each alternate can painted outside is taken off the overhead conveyor and placed on a roller conveyor, along which it runs to the government inspectors. Here they place a lamp inside to inspect the quality of the paint. It's very important that the paint film should be even and unbroken. We have a view of the interior of the can the way the inspector sees it. You can see the glossy, even coat of paint applied to all interior surfaces. The cans are then conveyed over the gravity conveyor, allowing them to cool before the plug is assembled and the final outside coat of paint is applied. The plugs are placed on the chain already attached to the handles, a rubber gasket having been previously assembled to the plugs. This operation squeezes the hook onto the chain. The tool is operated by air pressure. The plug is first lightly assembled. And then finally screwed into the can and tightened securely. Government inspectors pass the cans before they reach the stage where the final outside coat of paint is applied. This is done by flow coating. The cans are placed on the overhead conveyor and pass into a bath with streams of paint flowing over the cans. This is drab olive green. The can changes its appearance from red to green in a few seconds. By this process, the paint runs into all corners, covering all surfaces with an even coat. The bottom is submerged in the bath. They are conveyed over draining trays and pass through the entire length of the factory to dry. They are then passed before more government inspectors, where the final government acceptance stamp is applied. Accepted cans are conveyed overhead to the loading bay, where they are removed from the overhead conveyor and pass into special vans where they are packed. The line brings cans at the rate of 720 an hour, one every 5 seconds. A constant flow of cans fills the van in approximately 2 hours, a total of 1,200 cans. A roller conveyor carries the cans right into the special vans built for transporting them to the railway. Another empty van waits at the opposite end of the loading bay so that the constant stream of loading is not interrupted. Another 6 tons of cans leaves the factory on their way to the filling stations. To describe the effort which has been put forward in carrying out the work you've seen, it is appropriate to quote General J.C.H. Lee, who when he addressed the employees of this factory said, "The construction and operation of this great plant is the perfect example of real teamwork between our two beloved nations. Britain and the United States have pooled their raw materials, their production facilities, and their labor to solve this major supply problem. Here, you of Britain have supplied the plant and those to operate it, and we of the United States have furnished the materials and the machines. It is proof of the fact that this is another breakthrough, another salient into the enemy's so-called fortress of Europe."